Rick Ramgattie, and I'm a security consultant here at Independent Security Evaluators. Today we're going to do another one of our live streams. Specifically, we're going to be hacking the Drobo 5N2. The Drobo 5N2 was one of the embedded devices we hacked as part of ISE Labs. And if you've been paying attention, we've actually done a couple of these live streams already. The whole purpose of these live streams is that we want to teach about the process of hacking embedded devices, not just about showing off some point and click type deals. So, like I mentioned, we're going to be hacking the Drobo 5N2, which is this nifty device that I have over here on my left-hand side. The Drobo 5N2 is an embedded device that we actually found on Reddit. One of my coworkers, Jacob Holcomb, asked me to find devices that I found cool. And what I do when people say to find something cool is I just go to Reddit and see what everyone else thinks is hype. And that happens to be this embedded device. There's a couple reasons why people like the Drobo 5N2. One of them is that it looks pretty sleek and it's got some cool lights. And the other one is that you can pretty much, quote unquote, throw new storage at it. And when you throw new storage at it, it figures out how to send data between those drives and then have to encrypt them as well. So it's supposed to be encrypted at rest. That's another one of the cool functionalities. But we didn't look into that. What we did look into was the security of the device, which is what we're going to do right now today during this live stream. And as part of ISE Labs, this version of our research project involved looking for exploits in network accessible services or vulnerabilities in network accessible services and developing exploits for them. What that usually means is that once we hook up our Drobo NAS to our home router or the internet or wherever it is that you decide to set it up, we want to see if we can access any of those services and exploit them as well. For our research, we did two different types of situations with each device. One of them was its default configuration. So right out of the box, we would just hook it up and start hacking at it. The other was that we would put it in this Christmas light type situation where everything was turned on and we would try to identify vulnerabilities. The one that we're going to work on today is actually its default configuration. So this device you can hack it straight out of the box just the way that we did. And the vulnerabilities that we'll be showing off is actually in a protocol that's used to communicate with the Drobo. This protocol specifically is a custom protocol, and I actually saw this when I was on that Reddit board for the Drobo, which is what piqued my interest and made me want to buy it. And we'll go over today about how it's really not that much of a complicated protocol and about how anyone without any form of authentication can interface with these devices and make it their own. One of the goals that we had as part of the research lab was that we wanted to identify vulnerabilities that would allow us to get full control of the device. Sometimes you'll hear people call this weaponizing a device. It's because it's kind of a hype thing to do or just cool because it sounds like you're going to use the device as part of a botnet or some other nonsense that you feel like you want to do. In our case, we only want to do this from the perspective of take the device and see if we can get a remote shell or anything that allows us to interface with the operating system. Enough about that. Now let's actually get into the nitty-gritty details about how we hack an embedded device. This is a network attached storage device, or NAS. So there's a couple things that we thought about when we got this device. This was one of the ones that we hacked later on, so we had some experience with it. And usually when you're working with a NAS device, there's a web application involved that allows you to interface with it. The Drobo NAS doesn't have that, by default at least, it doesn't. What it has is this thing called the Drobo dashboard. And the Drobo dashboard is an application provided by Drobo for interfacing with the device. And as soon as I switch over to my screen here, you'll be able to see what I'm talking about. Sam, you want to switch screens? And here on my screen is the interface for the Drobo dashboard. Right now, although it's very tiny, you can still see it pretty well. The Drobo NAS itself is, as soon as you get there, you see this little screen. Our Drobo is here, in this little box here that's colorful. I like the colors are really soothing and they're part of the experience. And after you click on it, you'll see your Drobo NAS and its current state. I'm already logged in as the admin user for showing off this functionality because I wanted to look at what it is that you can do with the Drobo dashboard. So one of the things that you can see here is that it gives us information about the device. Here we see that it is currently at 192.168.1.12, which is good because we will need that IP address to interface with the device. The MAC address and all that, the subnet mask, and a couple other cool information. There's also the health for the drives. Scary yet important feature about this device is that whenever you move it a little bit too much, or it does have to go through a reinitializing phase. I had another live demo of this device previously, and I moved it a little too close to when I had to do the demonstration, and I had to reinitialize all the drives. For those of you who attended TorCon, you can probably remember that pretty well. When you click here and the dashboard preferences, you'll see that there's other functionality as well. So you can, the Drobo discovery settings. The Drobo discovery settings is what allows you to find Drobos on your network, or in this case, it's what allows you to be able to find the Drobo. In the tools section, there's a couple other really cool tools. One of them allows you to turn the lights on, shut it down and restart it, which is things you would expect to do with the device. So in those little lights that we saw just now here on the dashboard, these lights actually flash, and it's kind of cool looking. I have to admit to that. And it is part of the built-in functionality for the Drobo. What we'll be doing later on today, as we reverse engineer the protocol, is that we're going to use those, we're going to turn those lights on and off, or at least we'll try to, as part of the showing how you can reverse engineer the protocol and interface with the device. So other things you can see here is that when you click on the Drobo, it has a serial number. Where is it? And it's right here. So serial number is DRA 173, whatever. The number really doesn't matter for now, but just knowing that it's there is important. And it is going to be important later on. So a lot of you are probably thinking right now, well, this is just an application for interfacing with the Drobo. Usually when you want to hack an embedded device that uses a web application, it's pretty easy, right? Or let's not say that. If you want to start looking at it, it becomes a little bit easier if you have the web application. You just pipe all your traffic through Burp Suite and then you're good to go. In this case, there isn't. Like I mentioned before, the only way that you can interact with the Drobo is through the Drobo dashboard. And because that's the case, and there doesn't seem to be any settings anywhere that allows you to set up a proxy or anything like that, if you want to interact with the Drobo, you're going to have to do it through the Drobo dashboard. Or at least that's what most people suspect. Now let's go through let's try to figure out how it is that this is happening. One of the things that I want to do is that I want to figure out what ports are open on the Drobo dashboard. And usually when it involves figuring out what ports are open and it's a network accessible service, that means Nmap. So let's go ahead and look at Nmap now. Lucky for us, I already have a Nmap output. I ran an intent scan, or what most people refer to as an intent scan that runs Nmap. For the flags, I can just do them right here with you now. It's going to be Nmap -T4 for the timing delay, -A, -V, and then after the IP address for the device, which is 192.168.1.12, if I remember correctly. Let's go back to the Drobo dashboard and check it, just to be safe. And clicking on the Drobo dashboard here, and clicking on our network information tab, we see that it is in fact 192.168.1.12. This scan is going to take a little bit too long, and I did prepare an output already beforehand, so we wouldn't have to wait for that on the live stream. But just to make sure that the device is still there, so that we're all very aware of it, we can ping it and it's still there. So we're good to go. Let's go ahead now and look at that Nmap output. We're going to open it up with less, which is just a tool for looking at files. And we're going to look at the default Nmap output. So here it is, guys. Here is the result of our Nmap output. I ran it a little while ago, as you can see here by the timestamp. And here are the ports that are open on the device. The ports we see here are 445, 139, 548, 5001, and 5000. So the nice thing about Nmap is that it's going to tell us, or it's going to try to figure out what's running on each of those ports through some fingerprinting. The fingerprinting has let us know that port 139 and 445 are most likely Samba, and it gives us a Samba version. That's important to note as well. Although it's not going to be part of this live stream, when you are identifying attack surfaces on anything, you should be making note of the version numbers. The version numbers will help you identify if A, there's already a known vulnerability in the service you're looking at, or B, if it is something that you really need to dive into to try to figure it out. On port 548, we see that we have NetAttack, which is just another service running there. It's really not important for what we're looking at right now. What is important, though, is that on port 5000 and on port 5001, there seems to be two services that Nmap was not able to figure out. So one of them is called UPnP question mark. I myself am not familiar with anything called UPnP question mark, so I'm going to guess that it's something custom. And port 5001 is running complex link question mark. Same thing, I don't really know anything that's called complex link, so there must be something else running there. So it looks that when Nmap connected to the Drobo on port 5000, it returned some XML. It looks like the same thing happened on port 5001, but this XML has a lot more line. It seems to be escaped for some reason. We'll look at that as well. Let's go through the rest of our output just to see that there isn't anything that sticks out at us that might be useful. Here's after some more scanning, it says that it suspects that it's running a Unix type operating system. That's going to be handy. That's actually a trend with a lot of embedded devices. A lot of them run something that's Linux based because A, it's free and it's easy to work with, and a lot of people are already familiar with building embedded devices with a Linux type operating system. There are tools out there like BusyBox that really make that experience of building an embedded device way easier. And also, it takes a lot less effort, which is important. When it did some SMB OS discovery, the same thing I said before, it gives us a Samba version. It says that the OS is 6.1, which it was a nice try, but no cigar, really wasn't that. And it said some other things as well, such as that it seems to be running the SMB security mode of with message signing and authentication level as user. And that's the end of our output. So there were two important takeaways from what we did just now. There's something running on port 5000 that we're unaware of, and there's also something running on port 5001 that we're unaware of. Like I mentioned just now, when the Nmap scanner tried to connect to port 5000 and returned an XML payload, let's see if we can get the same behavior. So for that, we're just going to use netcat 192.168.1.12. Forgot to give it a port. And on port 5000. When we give it that on port 5000, it looks like it returns some XML. Note that there was no authentication involved for getting this. All we did was connect to the device on port 5000 with nothing else. We just used that NCAT, no smoke, no mirrors, just connecting to it directly. When you connect to the device, you can see that the serial number is over here. That's actually the same serial number that we saw just now. So it's a DRA 1732. I'm not going to read the rest. We can just go back here and see that it is, in fact, the DRA 1732. It also shows us what version it's running right now, running 4.0.5, the release date for that firmware, the architecture, and scrolling down, there's a couple other interesting tidbits as well. Some of them is the current hard drives that are in the device. I pointed out just now that the device has 3 hard drives because of the 3 lights. So if we go back to the device, we'll see that there's 3 hard drives. When we connected to it just now, it actually told us the same thing. It told us that in the first bay, there is a Seagate hard drive. And I'm not sure if I remember correctly, but it does say the physical capacity as well. Same thing goes for the second one, and same thing goes for the third one. Awesome. So have in mind that there is no authentication, but this isn't really sensitive information. At least it isn't so far. We were able to connect to the device without any form of authentication. We're able to extract a fair amount of information. It may actually be information that we don't want people to know. Like I pointed out just now, it has the exact firmware version running on the device. As an attacker, if I wanted to see if this device was vulnerable, it'd be pretty easy to just go and see if that version number has any known exploits, instead of going through the process of identifying exploits or identifying vulnerabilities and developing exploits from the get-go. So let's keep on going down. It doesn't seem like there's anything interesting here other than a couple other details, such as the if Drobo apps are currently enabled, which is here. Drobo apps are the way that you interface with a Drobo. Like I mentioned, the Drobo device seems to be something that a lot of people like, and one of the reasons why is because it offers a lot of applications, including, let's go to the dashboard and look at them ourselves. In the Drobo App Store, some Drobo apps that allow you to access the device over a web application, it's called Drobo Access. We'll be looking at that later as well. And some entertainment applications such as Plex and Twonky, and some system utilities that allow us to install Bash on the device, Dropbear, which is going to allow us to SSH on the device, and a couple other utilities that'll help us make the most out of it. It even has Subversion if you want to store your source code there. Cool, so that's enough of looking at port 5000. Let's see if there's anything on port 5001. Connecting to the device on port 5001 doesn't give us anything back. So if you notice just now when we connected on port 5000 gave us back a lot of data, the XML payload. Port 5001 didn't give us anything back. So it must be used for something, we just don't know yet. Now, the next thing that we did as part of our research was that we wanted to still figure out how it was that the Drobo was communicating with the desktop client. So what we decided to do for that is that if the XML payload seems to be something that comes back in plain text, there's no encryption after all. So it must be the case that, or it might be the case that the rest of the protocol is also unencrypted. And if we're talking about looking at network traffic and looking at network traffic without any form of encryption or anything else, we should probably be thinking about Wireshark. So let's go ahead now and look at Wireshark to see what it is that we have there. I prepared a Wireshark wire capture before this because I didn't want to have to go through that hassle. In this case, port 192.168.1.26 is the source, which is us. It's going to be the one holding the dashboard, and 1.30 is going to be our destination. So let's go ahead and look at that. And if we look here, you can see that on port 5000, so it's upside down. We are on port 1.30, or we are 1.30, and we're speaking to 1.26. And we're going to try to communicate with whatever's running on port 5000. So let's go ahead and look at that wire capture. Let's look at the beginning to see what we got. So the first thing that we see on here, and hopefully that's big enough for everyone, let's look at the hex dump since it's a little bit easier to look at. Here in the hex dump, we can see that the first couple of bytes seems to be just the text dry NAS D and a null at the end, which is just these 2 zeros, then a couple more nulls, and it seems to be a number, so 445241, 313733, so it just goes on. And it seems to be repeating it twice. So that's important to note. Let's see what else we got. So that was the first stream. Let's see if there's another stream here that looks interesting. Here's another stream. Let's look at this one. So this seems to be very familiar, or it looks very familiar to me. It looks like it's the XML data that came back to us from when we connected to the device. So that was what was on port 5000, so that does make a lot of sense. Let's see now if I can increase the zoom here for good people. So then after, everyone can see a little bit better. And plus, nope, no zoom for anyone. All right, zoomed the wrong screen out. But anyways, let's see see if there's anything else on stream 2. Stream 2 now, it's communicating with the device again. And this one is the authentication process. So what we saw just now. And stream 3 is another one, but this one's way bigger. This may be the same thing again. So this is the data that came back to us. We'll just keep on going down the streams to see if any of them end up being what we want. Interestingly about this one, this is on port 5001. This is not on port 5000. So this was the other port that was on the NAS that was offering a service. Let's check out that stream next. So this is also different. So if you notice here, there is a request at the beginning, and then after, the NAS device is now responding with XML, but the XML is different every time. But it didn't take us long to figure out that these were the commands that were being sent from our client to the device. Our requests were the ones in red at the beginning here, and the server's response was the one in blue. So let's go ahead and look at that in hex, or in the hex dump as well, to make our lives a little bit easier, and it's a little bit easier to follow along when you can actually see what bytes are being sent. Cool. So the first thing that we see is that there is a request sent from us with a bunch of nulls and some data at the beginning. And then after that, there is another one. The server just responds with some dry net TM, and it comes back with nothing but that and some nulls at the end. And then we send another request and we get another response. So now it's a process of, we're going to go through a process of reverse engineering this protocol. So let's go ahead and do that. For that, I'm going to use Python. I want to communicate with the device over TCP, and I want to do it with just a script to make it a little bit more transparent, and I don't want to have to compile anything while I'm doing it. So let's go ahead and do that. I have a layout of what it's going to look like already for us. It's called Drobo Lights. And let's just talk about what's here already so that everyone's able to follow along home pretty easily. First, we have the IP address of the device. It is 192.168.1.12. The port that we're going to be speaking to the device on. So we want to speak to the device while it's listening on port 5001. And the buffer size of how we're going to receive the responses. Here, in this line number 7, we create a socket. And then after, we use that socket to connect to the device, which is that TCP IP, which is the device's IP address and TCP port, and we send the preamble. Let's go ahead now and copy that in. So for that, we have Wireshark right here. And let's go ahead and do this. So I'm going to send this hex to the device, and I want to see what comes back when we send it. So let's go ahead and do that. And I want to clean this up a lot, so we're going to use the magic of Vim to remove all these unwanted things, and then after, we're going to format it correctly. Select all of these, change spaces for hexes, because we want it to be in hex. Missed a couple here because there was no space. And then after, make it all one line. I missed some spaces at the end there. Let's take care of those beforehand. Make the whole process a little bit less painful. Or just put it all in one line, remove the spaces. That would also work. Remove spaces here, all in one line. We call this one preamble. This is going to be a debugging process because I'm doing it live with you guys right now. So we're going to now issue a request with this and see what comes back. So with s.send, we're using the socket we created on line 7 to send the preamble we created on line 9. And then after, we're going to print anything that comes back. So let's go ahead and do that. So Python, Drobo lights, pi, and we're going to pipe that into XXD because I want to see the hex that comes back. That seems awfully familiar to what we just saw when we connected to the device. So let's go ahead and look at that. It's the message drynet, and then after some characters at the end. But there's something different about this. This one had these and ended in 0, 1. This one, and some nulls. This one ends in 0, 1 as well. After the 87, there's a new line at the end here. But the new line is sent by the device, so we're good. Let's see what now happens if we do the following. I know through debugging already that we did while we were looking at the device that command 26, which we're looking for right now, command 26, where are you, command 26, is the one that's used to turn on the lights. So this one right here. But like we saw before, there's some extra details about this that we're not seeing right now. So what I'm going to do is I'm going to copy this string out of here. And then after, I'm going to look for it in hex mode so we can actually see what's going on. Not in arrays, hex mode. There we go. Hex mode. And we still have to search for it. Too bad. In here, we'll see that the command is going to say, this is similar to what we want. But here, if you notice, there is some data at the beginning, right after the drynet TM, that's important to us. First is the string, drynet TM. Then after, the character 0A, 01, a couple of nulls, and then the character AD. While we were assessing this device, we found out that this was actually, these last 4 bytes were actually the ones that were used to say the size of the following request. So 0 AD is what's the actual size from here till the end. And that was pretty neat, and it took us a while to figure it out. Shout out to Ian Sinderman, because he spent a long night trying to figure that out and helping me reverse engineer this. So let's go ahead and look at that now, and let's copy it over. But this is not the one I want, because the interval here is set to 0. Through experience, I know that if the interval is set to 0, that's actually for turning the lights off. And if the interval is higher, that's for turning the lights on. So that means that we went too far. And 61, that's 61 as well. So a lot of 61s here. There's a 14. Here it is, command 26. So we're just going to copy this guy out, put him into this file right here. Seems like Sam has a question for me. What's your question, Sam?
Do you want to show the status of the Drobo before and after you create it?
Oh no, this is not going to work. This is part of the live stream. So, how's everyone going in the YouTube chat? Has anyone had any questions so far? Here we're going to clean up like we did just now. And this all on the same line. Oh, didn't want to do that. Do this first. And swap out spaces for some X's. And then after, add some more X's here. Hopefully everyone's able to follow along home. If there's anyone on the stream that feels like I'm going a little bit too quickly, or if you have any questions, please reach out. I'm more than happy to answer your questions. Also, you can hit us up at our Twitter account, which I feel like Sam put somewhere. It's part in the description. And because mostly what I hope people are getting out of this, we started these at ISE because I want people to learn about hacking things. I just don't want them to feel that it's this mystery or that it's something that's out of your reach. It does take a lot of time to learn, but it's not something that people just can't learn. And I really hope that everyone has an opportunity to do that. And if my live stream is the one that inspires you to actually get into hacking, that will make me very happy. So here we go. We're gonna add it as we did with the other one. We're going to make it into a string. And then after, we're gonna call this command. Let's call command 26. And we need an equal sign. Whoop, wrong place for that equal sign. Here we go. We're going to send this as well. Hey Sam, can you switch to cameras, please?
You want to look at the Drobo?
Yes, I'd like to look at the Drobo now. Well, let me swap these last two characters so there's no fanciness. Hands off the keyboard. Sweet, so this is how the Drobo is right now. As you can see, the lights are just in a stable mode. So the thing that we saw before where it said that the Drobo lights, we've come to call it party mode. And what it does is that it flashes the lights in the front on and it makes it look kind of like a rave. And who doesn't like raves? So Sam, if you can switch it back over now to my computer, I'll go ahead and run this script. For those of you paying attention home, here's a script that hasn't changed all that much. Add a new line for aesthetic reasons. I'm gonna send them over. Python Drobo lights pi. Hey, we got it. It worked. Sam, move that camera. So now you can see it's actually in the state of party mode. The lights on the bottom are doing its thing. The lights on the side are doing its thing. And it does, so admittedly, it does look pretty cool. This was the most exciting thing. You can switch it back now. This was the most exciting thing for Ian Sinderman and I when we were doing this. We just couldn't get over the fact that, hey, we were able to turn on the lights. There are other devices that are going to be in our live stream session that are going to do a similar thing. This one, it's kind of silly. I know it does the lights. I'll give you a shell in a minute. Just hold on. But it's important to see that there's no authentication on this. Anybody that knows the details that we just covered can actually get into the device. Or in this case, turn the lights on, and it gets better, way better. But taking it back a lot, the thing that matters here is that without any form of authentication, you were able to perform a state-changing effect on the device. Although it's only turning on the lights, we can do other things as well. You can actually enable applications and install them, and you can do other things that we would consider malicious, like maybe delete applications or anything else. Like I mentioned, there's SVN on there. So if you did actually use it as a source code repository, that might actually not be the best idea because somebody could probably just lift everything off of it. I also mentioned that there's SSH on there, and there's also a web application. Next, I'm going to use SSH to help you guys find vulnerabilities that give you a shell, or just go through that process, which is what matters to me. I just want you to have the process down. And we're to see that we did go through a process for identifying these things. It's not some thing where you just walk in and find shells. You actually have to go through a lot of hard work to find these things. So, despite me being really excited about these lights, we're going to move on to the next phase. For this one, we're going to SSH onto the device and extract the files from it. Or I don't want to extract the files because it's going to be a huge pain. What I do want to do is that I'm going to SSH on it as the admin user, 192.168.1.12. Put in the password, and here we have a shell. So yeah, you can see it pretty well on the screen. And next thing I want to do is become the root user. Same thing again. There we go. So nothing fancy. We're in this directory right now as soon as we SSH'd in. So the application SSH was already installed in this case. We're gonna get some more. Don't worry about it. So one of the things that I mentioned is that we installed a web application on this. Let's see if we can find it. So when you install the web application, it's actually listening on port 8080. So let's go ahead and go there in Firefox. Lucky for me, I cleared my history right before we came to this. And it's called Drobo Access. And it's because Burp Suite is currently intercepting. I'm sure Josh loves that right now. So as the Drobo Access is currently listening, there we go. Finally open. Sweet. So the Drobo Access application allows you to interface with the Drobo. I want to find something that gives me a shell. So let's go ahead and find it. Step A is going to be to figure out where Drobo Access is and figure out what application is there. So let's go ahead and try to find that. So if this is, if all is fine and dandy, there should be a web server. So let's start with, yeah, PS should be fine. And we want to grep for anything that has maybe HTTPD. Ah, HTTPD. And it's in this directory called /mount, Drobo FS, shares, Drobo apps, and there's more there. So let's go here. For those of you following along home, hopefully all of you are, the whole nation. You can actually, the reason why I grepped for HTTPD was because I suspected that was a web server. One of the other things I could have done was just grep for Apache or Nginx or something else like that, so to figure out what it is that's being used right now for serving the web application. There's other things you could have done as well. In Mr. Joshua Meyer's live stream, what he did is that he searched for PHP because all the files ended in PHP. In my case, they didn't. What Mr. Sinderman did in his live stream was that he searched for things that ended in PY, and it was because it was a Python web server. Mine isn't either. And I think, I forget, Mr. Marani's, it was actually some compiled binaries. And he just grepped for a very long time and used set and a bunch of other really cool things. Let's go there. And while we're in that directory, let's see what's there. Lucky for us, there's Mr. Drobo Access. In the Drobo Access folder, we have a bunch of interesting details. There is an app folder and there's an Etsy folder, bin, libexec, and www. I'm torn between the app and the www, so let's go to the www first. I want to, and there is some scripts in there. Oh wait, mine is in fact PHP as well. So this is interesting. And so something that I've come to learn about when you're doing a source code assessment is that one of the things you should focus on is finding dangerous functions at the beginning. So a lot of languages have functions that are quote unquote dangerous functions. These are the type of functions that allow you to perform some type of behavior that may end up being pretty bad. For example, executing a network or just executing commands on the operating system that's running the application. Some of the other ones are anything that involves encryption, usually because there may be cool things that may be happening there, or random numbers, or other functionality that allows you to do something that may go wrong. So let's go ahead and look for that. PHP, there's a couple really interesting ones. So let's go ahead and grep for some of them. We'll grep for system, if I can type system, in the current directory. And there's nothing there. Let's try exec maybe. What's the other PHP one? Let's go to Firefox. And I think that the other one I'm looking for is PHP exec. Oh, shell exec. Or there's two of them, shell exec and exec. So let's try both of them. Let's start with shell exec. Ah, there's one. So let's go ahead and look at that one. It's in include/Drobo. So let's open that up in good old Vim and drobo.php. Ah, there's no Vim. That's sad. So let's try VI. And it was shell exec. So here, there is something called get log file that calls shell exec. What else calls it? Just get log file. Are there any other ones? Okay, so let's make note of that one. So I would open up another thing in tmux, but I'm terrified of it. So we'll just keep track of that in our heads. Let's open up exec next and see what's. So obviously shell exec is going to be with exec. I'm going to add a parenthesis so that they know it's a function. Yeah, that should help. There's a bunch of them. Whew. And let's go ahead and look at those. So there's this very large one, which is most likely JavaScript ruining everything. And come on, there we go. And yeah, the first one is just some JavaScript. So let's see if we can exclude that. I can exclude there equals JS. Is that not one of the options in this version of grep? So sometimes you'll find out that when you're working on some of these embedded systems, the version of the tool that you're looking for is not there. Hence, this one is the one that comes with BusyBox, so it doesn't have excluders. And what we're going to do instead is we're going to ignore the one that's with JavaScript and just scroll. So there's a couple here. There's some includes my Drobo, includes Drobo Access, and includes Drobo. Let's go ahead and look at some of these. So let's look at includes Drobo Access. There's no VIM. There's going to be a VI though. And if we look for a shell exec in here, we'll see that there's get version calls this, and then after so there's list users, only DA users, status users, and a couple other enable. Oh, this one's interesting. Didn't we just see an enable user in this directory as well? Isn't there? Yeah, there's an enable user here as well. So let's go ahead and look at that. And in here, it seems that whenever we issue a request to this device, it takes the username and the parameter enable. So because it's a request, it could be either a post or a get. And it checks if enable is equal to true. And if it is, it calls enable user with their user's username. Wasn't that passed as a command line argument? Let's go ahead and look at that again. Enable user. So what enable user does is that it takes the user, the parameter that was passed, which in this case was the username, and it passes it straight into a string that's built, that's called command, and then it's called shexec command. Let's see now what we can do with that. We go back, it's enable user, so it's going to be Drobo access enable underscore user .php. We go to our browser, we go to enable underscore user .php, and let's say we provide not provide any parameters. Okay, cool. User cannot be disabled. Let's go back, look at, see if that error message is actually something we can use. Pardon the screen dancing. We'll get back. Oh, not there yet. There we go. One more. There we go. So if we look at enable user again, we'll see that here's the error message. Could not be, so user blank could not be blank error code. So for those of you that are home thinking XSS, this also works for XSS, but if I really had to weigh it out and say XSS or command injection, I'm going to go with the command injection. So let's go ahead and try that out now. And if I do a get request parameter with the value username, so username equals test, it should come back saying user test. All right, we know that our parameter is in there now. Let's zoom in. Much better. If I hit enter, it's going to get small again. Oh, thank you, Firefox. And next we're going to do enabled. So if enable is equal to true, it goes to enable user. So let's say enabled equals to true and enabled equal to true. So the user test cannot be enabled, which is still progress. So we're going to see that enable user and enable is equal to true. Let's go back and look at the other program one more time so we can look to build our command injection payload, or at least our test payload for command injection. Enable user. And here we see that it builds the thing, builds our command with this. So we should be able to get command injection in here by using backticks. That should work perfectly fine. Let's try that out. So with a username of test, let's put in let's send this to something that makes it a little bit more visible for everyone. Here we go. Send this over to repeater. Let me make my screen a little bit bigger here for everyone so that you can all enjoy it. Let's make it right here a little bit bigger as well. The dialog is bigger, and yep, that seems visible. What do you think, Sam? Sam says yes. And
living in the past.
yeah, Sam is currently living in the past. Get with the time, Sam. And here we're going to use our test payload. So we saw that there was a quotation mark, so let's put another quotation mark there. Let's touch test ISE. I'm going to put that in between backticks. And that should work. Let's go ahead and give that a go. Oh, bad request. Is it because there is? Let's try this out. Nope, none of those. Touch test ISE. Still bad, huh? Let's try without those. Let's just try test. Progress. So test quotation mark. And we're going to do touch test ISE. Put another semicolon here. Quotation mark. Let's try that out next. Oh, it might be because we need to encode these spaces. Let's try that out. There we go, much better. So let's see if that worked. And would you have it? Here's a file, test ISE. Zoom in more. Test ISE. Let's do it again, just so that everyone can see it. Test ISE 2. Should create a file there. Test ISE 2. Live. But this is touching files. Cool, not that cool. How about we get something else now? Let's check if there's anything in bin. It seems fun. That might be some fun. cd/bin. Well, that's too big. I can't read this. Anything in there that looks interesting? So there's, I guess we could zip some stuff up. Not as fun as it sounds. Move some stuff around. If you were going to delete some files, that'd probably be the way to go about it. Or rmdir, just remove some dirs directly. Or rm, that's also used for removing files. What about something that gives us a shell? What would we use? Is there telnet? Which telnet? D. Ah, there is one. User sbin telnet D. Didn't it just say it was there? Of course, I can't cd into a file. Silly me. Here we are. Oh, there's also remove shell. That's a cool name to it. I want that to be my hacker name. Remove shell. Cool, so let's try doing that next. Instead of touching, we're going to open up /user/ why would I not copy the whole path? Here we go. I want it to be remove shell. Remove hyphen shell. The hyphen is crucial there. And let's go ahead and send this away. Let's check to see that there's currently nothing on that port. That's that. That's that -ATOMP. Much better. Scrolls. When we scroll, there's something listed on 22. That's probably FTP, SSH. 139 is SMB. 5000, 5001s. So the stuff that we saw before, guys. And let's see now if we can get SSH. Or, sorry, telnet. Telnet D. And let's do C. Telnet D -help. Is there a help? And we want it to be listening with a shell. So it's going to be -l/bin/sh. Do we have a sh? Yes, we do. Go ahead and do that. So telnet D %20 -l %20, which are spaces, /bin/sh. And let's go ahead and try that out one more time. See now if there's anything on stat for that port. If we're lucky, if I will just try again. And port 5000, 5001, 139, 22. I don't see anything for telnet. Oh wait, port 5002. Listening which that's UDP. Not what we want, but that is interesting. And telnet D for that, so -L. It's gonna happen. Let's just see if we can start telnet to begin with by itself. User bin telnet. That should make things better. Port 23. Busy box. All interfaces. And let's see if we can connect to it. So exit very quickly. Netcat, or yeah, telnet 192.168.1.812. Oh, no shell yet. Let's try again then. For telnet D. Oh, I should probably give it a port. I'm gonna SSH back onto the device. Fast forward 123 bang. And sudo bash because I want to be root. And let's try telnet D -L/bin sh. If I did it manually, this time it should be the case that it listens, right? So here we see that it does start, but it's on port 23. If that's the case, we should be able to SSH on it or telnet onto it. Here's the thing, I do have the exact exploit I used before. Here it is. And it's the same one. That's interesting. Let's go ahead and try it now. Oh, you know what? It's probably a different port. Lucky for us, I have this ready to go. I don't know why I tried to do that. Here we go. 1.12. And we'll see what ports are open. And after we see that, we'll be able to see what's that? Yeah, but it'll be good to go in a minute. Oh, yeah, it works fine now. Yeah. So netcat 192.168. That's exactly why 12 on port 23 Let's go ahead and SSH back onto the device now. Admin at 192.168.1.12 and sudo bash. And let's use netstat now. netstat-a2mp. And let's ps box. Let's search for telnet D. Oh, I am currently running it with -bin sclear. That might be why. So let's kill 754. Let's try our exploit one more time. To grep for that. Let's exit twice. Netcat 192.168.1.12 port 23. And ladies and gents, we have a shell. So that was the entire project. You probably should be home clapping right now. Your kids are probably enjoying it. Hopefully everyone enjoyed that, and hopefully everyone got a lot out of it. Like I mentioned, We do have our ISE Twitter, and if you do want to just reach out to us so that we do more of these or more of these training type engagements, I'd love to do them. Also, if you just happen to know of an embedded device that you would like for us to hack, we're also more than willing to do that as well. Now, as part of the IC Reach Out, we've hacked a bunch of embedded devices, and there will be more live streams. We've also done a couple of really interesting blog posts, and we will be delivering this content as well as at conferences. If you do want to drop on by and see what we do, we're also happy to do that as well. Hopefully everyone got the whole point of this, and that's that this device had an unauthenticated protocol that would allow you to install whatever applications you wanted, run arbitrary commands that would allow you to change the state of the device, and because there were also vulnerabilities in the applications served by the device, you could easily get a shell, or through a lot of struggle like I did. So as you can see, the main thing about this Drobo device is that a lot of people install the Drobo Access application that I showed in my web browser. So if you were to install that, you could see that you're one GET request away of having someone get a shell on your box. And hopefully a lot of people take this seriously. And if you do want to reach out to hear about more vulnerabilities that we've done, you can reach us out on Twitter. I think Sam has our email on there as well. And we've also done other case studies for things in the area, such as the same or similar So Hopelessly Broken research we did in 2013, and then other research we're going to be releasing soon. Hopefully everyone enjoyed the stream. I hope you did enjoy all the time you spent doing it. And if you want to hack more things, just do it. Thanks. Bye.